Hi, this is Lakshmikant Tiwari. In this lesson, I'm going to show you how you can work with the human activity recognition using convolutional neural network. So I'll be showing you how you can classify human activity recognition using accelerometer data with the accuracy of 91 to 92%. And then I'll be also showing you a learning curve to understand when your model started overfitting. And then finally, I'll show you a confusion matrix, which really shows a lot of the things about your model. Like it shows you that the sitting and the standing can be classified with 100% of the accuracy, but the model got confused with upstairs and the downstairs, but it has shows the accuracy, a good accuracy in other cases. So all these things I'll be showing you in these lessons from a data preparations. There are so much data preparations, which is actually a really very important for your machine learning, the techniques. And then I'll be showing you how you can remove these errors, etc. Alright, so apart from that, if you haven't watched my previous video, you can go ahead at my channel KGP Talkie and you can watch my previous videos. I have been making so many videos on a TensorFlow 2.0 and on the machine learning and the Python as well. I have also made few videos on a feature selection so that you can get a better accuracy and reduce the training time. And then I have a machine learning the tutorials for the beginners, and apart from that I have for Pythons and for data visualizations. And then you can go ahead at my GitHub repository from where you can download other codes, and this code will be also available at my GitHub repository. You can get the link into video descriptions. And before we go ahead, you can go ahead at my channel and first subscribe and press the bell icon so that you can get updates directly into your inbox. Okay, so without wasting time, let's go ahead and start a step-by-step coding for this lesson. Alright, so in this lesson, we will be given a one accelerometer data in 3 dimensions, X, Y, and Z. And we need to classify what is the activity of a person. So there are 6 classes, I'll tell you that later. But this is overall architecture of human activity recognition using accelerometer data and convolutional neural network. So in which we will be given X, Y, Z data along with the timestamp, and then we will be applying here convolutional neural network. Basically we will be applying here 2-dimensional convolutional neural network along with a few hidden layers, and then finally it should classify in out of these in one class out of these 6 classes. Like a person is walking downstairs, or person is jogging, or person is sitting, standing, upstairs, or walking. So these are the 5 classes in which our algorithm will be classifying it using convolutional neural network. And so the data set which we will be using, it is available here, and this link of this file is given into a video description, and you can go ahead and read in a video description. So let's go ahead and click this link. So this link lead us to a wireless sensor data mining, where we have 2 types of the data, one for activity predictions and another for activity tracker. So you can download this activity predictions basically, and this is done into a laboratory condition, controlled laboratory condition. So I have downloaded this data from here, and then it will download a zip file there. Once you unzip this file, you will get here these files. In these files, the first file shows that the readme, it tells about what is this data about and who had prepared this data. And apart from that, we will be basically working on this data. So this data contains here a user ID, and then the activity, and then this is a timestamp in a millisecond perhaps, or it is a microsecond, and then here we have X, Y, and Z data. But the one thing is, notice here that this data is not fully structured, and if you try to read this directly into pandas data frame, you won't be able to read this, because there are few lines which is actually very jiggly wiggly, and they have got mixed up with another line. So it will not load directly into your pandas data frame. We need to do some pre-processing before loading this into our data frame. And this file tells about the raw data. That means it tells about 38% of data is contained for walking, and 31% for jogging, 11% for upstairs. That's mean you can see here there is a huge unbalanced data. So only the 4.4% data contains for standing, That's mean we need to also consider only 4% of data for other classes as well if you want to balance your data set, which we will definitely do. All right, so let's go ahead. I have placed this file in my working directory that you can see here. I have placed that directly, so I'll be reading this file. So let's go ahead, and apart from that, I'm using here a TensorFlow, and you can get here tensorflow.org. You can go ahead at tensorflow.org, and there you can install a TensorFlow beta version. And once you click on this one, and it depends at the time when you are watching this video. At the time of this video recording, TensorFlow 2.0 beta version is only available. You can do a pip install TensorFlow 2.0 to install a TensorFlow. So we are working here on Jupyter Notebook. I have already installed a TensorFlow, and here I'm importing a TensorFlow as a TF and sequential model from TensorFlow.Keras, and also I'm importing a flattened, dense, dropout, batch normalization, convolutional 2D and max pool 2D from Keras layer as well, and then I'm also importing optimizers, ADAM optimizers. So let's go ahead and run this cell. You should get a TensorFlow version 2.0 RC0, which is beta version. And let's go ahead and import some additional libraries, which is also supporting libraries. And these libraries are Pandas, NumPy, Scikit-Learn, Matplotlib, and Scikit-Learn preprocessing, standard scalars, and label encoder. All right, so let's go ahead and start working with the loading our data set. So as I told you, and as I have been showing you in my previous videos, we have been loading our data directly using Pandas data frame. So let's go ahead and read our data using Pandas data frame and see what happens once we read this data. So we can read this data with it is inside the folder, this one, and then there we have wireless this data. All right, let's go ahead and read this. So once you try to read this data, it says that there is error at this line, and you will get, once you fix this line, you will get a similar error many times because this data is not pre-processed properly. So what we are going to do, instead of reading in a Pandas data frame, we are going to read it into a native Python file application, and then we will pre-process this file. So what we are going to do actually, we are going to first open this file, and then we will be reading a line by line this file. So here we have file is equal to open, and then open this file. All right, so once we open this file, then I'm going to read this all the file inside the lines variable. There we can write here file and then read lines. So it will read all the lines separately. Now what I'm going to do, I'm going to pre-process data line by line. See actually what happens. Let's say if we see here at the line number, the 13th actually 134,634. So let's go ahead and see what happens at that line. So let's open it into a sublime text. This says that 134 and 634. All right, 134 and 634. So that is somewhere here. $134 and $634. All right, so you should get it somewhere here. Yeah, you see here. So this line actually. So this line is creating a problem. It is saying that it had accepted just a 6 column, but it has got here 11 column. Why? You see 1, 2, 3, 4, 5, 6. All right. So these 6 column our Pandas data frame expected, but it has got here more columns. So, and you will get this kind of the error in many lines. So what we are going to do, we are going to just read these 6 lines, and then we are going to discard other lines. All right. And to do that, what we need to do, we need to apply here a for loop. So for I and then line in we are going to enumerate it, and then here you see lines. All right, then after that we are going to do with the try and except. So here with the try, let's go ahead and try it with line. Line is equal to line dot split. Why we are going to apply here a split? Because you see this is CSV, comma separated value. So we are going to read these values, and then it will split this after this comma. So this will be read separately, this will separately, and these are the separately. All right. Now line will be separated into a multiple in actually an array. So we are going to read a first 5 array. And one more thing you need to remember here, that's 6 digit. This last digit is also containing here this semicolon. So we also need to remove this semicolon. That means we also need to split it along with that semicolon. So what we are going to do here, last is equal to line 5, that's mean a 6th column dot split, and we are going to split it with semicolon, and then we are going to read a first value. All right, and then last is equal to last dot strip. If any with the strip we are going to remove if there is any white spaces in a string or a new line kind of. And then there is some error, I mean you will get some empty string as well. Then what we are going to do, if last is equal to empty string, then what we are going to do, we are just going to break this loop here. That's mean we are not going to store this data. Now let's go ahead and read all these 5 initial values where it will be stored. This will be stored into a 0th index, and this is first, second, third, 4, and this is read into a last variable. All right, so the temp is equal to, here we have line 0, and similarly we have line 1, and then similarly we have a line 2, and then similarly we have here line 3, and then similarly here we have a line 4, and then finally we are going to add here a last string. All right, so this is a string as of now. And then here what we are going to do, we are going to store it into some other universal list, which is I'm going to just write here processed list, and this is just an empty list. And then inside this process list I'm going to append, and then I'm going to append this temp. All right, and then here we have except. If there any error happens, then what would happen here, it is going to print that, okay, what it is going to print, that error at line number. So I mean it will print if any error happens at some particular line. So let's go ahead and see this, if any error happens. So it says that there are 3 errors happened while reading this file, but no, okay, no matter what, this has read all the file in this processed list. And if you print this processed list, you will see here a file is presented, and here it has a user ID, and then the activity, then XY, this is a timestamp, and then finally XYZ data, and this is properly formatted data. All right, so apart from that, now I'm going to create a columns. Okay, so what are the columns which it has? These columns are actually, we have first one is user ID, and then second one we have a timestamp, and then we have X, and then finally we have here Y. All right, and then here we have a Z, and these are the actually these are just 5. We are missing one. After user we have also activity here, so that's the activity. All right, so here we have these 6 columns. Now after these 6 columns, I'm going to create here pandas data frame, which will be created using pd dot data frame, and there in the data I'm going to pass processed list, and for columns I'm going to pass here these columns name. All right, so let's go ahead and see first few lines of this data, and here our pandas data frame is ready. So we have processed our raw data which was stored into .txt. All right, so this is ready for further processing. Let's go ahead and check overall shape of this data. This says that we have 343,000 number of lines. All right, so this is quite big, and there are 6 columns, which is user, activity, time, and XYZ accelerometer data. Let's go ahead and get the other information of this data. It says that all these variables are a string time because this is an object. And for a machine learning algorithm, what we need to do, we actually need to convert this time XYZ. These should be converted into a numerical data. All right, so let's go ahead and see if any null value is present in our data, and that we can do with each null and dot sum. So it says that there is no null values presented in our data. Now apart from this, and if you remember that on this, not on this actually, if you remember in this about file, I had shown you this is highly unbalanced data. All right, for standing it has just 4.4% of a data. So how would you make sure that what is the data, I mean how it is distributed? To understand its activity distribution, what we can do, we can just call here data activity and then value counts. So with this value counts, it will show you here that, so standing is having just 3,555 values. All right, so this is having a least number of samples. But if you see here, walking and the jogging is having higher number of sampling. And if we use this data as it is, then it is going to be a highly overfitted and skewed toward walking and the jogging. So we need to balance this data. All right. Balance this data. So what we will be doing, we will be also selecting 3,555 samples from all of other activities. And to do that, what we need to do, we need to actually, we need to get all these into a different data frame. All right. All right. So, but before that, let's go ahead and convert these the string values into a floating values. So what we can do, we can just copy here the data, and then here we have x is equal to the data, and then we have here x, and then we are going to call here as type, and in the as type we are going to call here a float, and similarly we are going to do for x, y, and z as well. All right. So here we have x, y, and then finally we have z. Let's go ahead and now see information in our data. Now what is the data types? And it says that these x, y, z is into a floating numbers. We don't need to convert others because we will not be needing these the users and the time. And the activity is a string, it will be a string, and after that with the level encoder we will convert it into a categorical variables as well. All right, so let's go ahead and first plot this data x, y, z for a few seconds. All right, so for a few seconds, that's mean one more thing you need to notice here is that in the raw data, if you see, you should get somewhere that it's a sampling rate is 20 hertz. That's mean the data is processed in 20 hertz. That's mean if you see here, fs is equal to actually the 20. All right. So what we are going to do, we are going to first plot it for each of these activity, this data for each of these activity, right? The jogging and how would you know? Yeah, the jogging, walking, upstairs, downstairs, sitting, and the standing. So I have already written a code for the plot. So let's go ahead and copy this code for plotting, since this is very, standard code for plotting. There actually what I am doing here, I am here with this plot axis, I am providing the limits to my x and the y axis, and also I am going to give a title here, and with this I am plotting xy variables. All right, so let's go ahead, and here I am passing a data. So here I am passing if activity in activities, that's mean I am going to pass all these activities separately. So it says that activity in activities, so I'll first pass the walking and then jogging, then upstairs, and so on. So similarly it will be plotted for 10 seconds. Okay, the 10 seconds activity for each of the data. So let's go ahead and see. So it says that we don't have the activities, and to understand that activities we need to get that activity. How would you get that activity? You see here the data.info, all right, and sorry, not the data.info, but this value counts actually having this indexes, which is actually the activity. All right, so let's go ahead and copy this, and then here we can say the activities is equal to value counts, and then here we can get with the index. All right, so let's go ahead, and if you plot this activities, you will see here. So these are the actually activities. So this is kind of the tuple. We are going to pass these activities here. Let's go ahead and plot this. So once we plot this for a walking, we see a data something like this. Okay, so but for a jogging, you see there is too much the variation in XYZ axis. But for upstairs there is less variation into a data, but for downstairs there is also very less the changes into acceleration. And in the sitting you see almost a flat, you are getting almost a flat. So in the sitting we actually don't get a much changes, and in standing we also don't get a much changes. But if you see in a jogging and walking, we get most of the activity. So this is how our machine learning will learn. If there is much activity, then it can classify into jogging and walking, and apart from that, if less activity, then it can classify into a sitting. For a human, it's really very difficult to visualize all these data, but for a machine, especially a deep learning neural networks, it's deep neural network, it's really very easy to memorize all these data patterns, and then they can classify it very accurately. All right, so with this we have plotted this. Now let's go ahead and start its further processing. And now what we are going to do, we are going to remove the timestamps and the user ID as well. So how we will do this? We are going to do with the df is equal to data and the dot drop. So inside this drop, we are going to drop first user, which is not necessary, and apart from that users, we also don't need a time. All right, and we are going to drop this from axis is equal to 1, and then we are going to get a copy of this data frame into our new data frame, which is df. Let's go ahead and see first few lines. So here we have activity x, y, and z. This is only important data which we will be needing for classifications. All right, so as you had seen there, this is highly actually imbalanced data, which we can also get from here as well. The def and then activity. So this is highly imbalanced data. So we are going to take only 3,555 samples for all other activities as well. And to do that, what we need to do, we need to make a different data frame for all these activities, and then after that we will append those together. Now to do that, what I'm going to do here, I'm going to first create for walking. And for walking, let's go ahead and copy this from here itself. All right, so here we have walking is equal to the df, and inside this df, the df, and then this is going to take all the data frame whose activity is equal to walking. All right, and that is going to be stored as a copy, and similarly we can do for all other as well, like we can do for jogging as well. So we can just copy jogging here and jogging here, and then similarly we can do for upstairs as well. So here we have upstairs and here we have upstairs, and similarly we can do for downstairs. So here we have a downstairs, and then here we have a sitting, then we have sitting, and then finally we have standing. So for standing we can do this as well. All right, so with this we have got these 6 different the data frame. but you see here standing is having least number of values. So what we are going to do, actually we are going to take first 3555 values, and to do that what I can do, just simply here inside this copy I can just create a head actually. All right, so inside this head I'm going to pass 3555. all right, so this we can copy from here, and once we copy this we can paste it here. Similarly we can paste it here, and we can paste it here as well, apart from that here as well. All right, so with this we will be getting only a 3555 data samples for all of these activities. Now we have balanced our data set. Now we need to bring all these together in a single data frame once again. So what I'm going to do here, I'm going to call it balanced data frame. All right, so the balanced data frame, I'm going to first create here empty data frame, and then inside this balanced data frame I'm going to append all other data frames together. So I can just do here append balanced data dot append, and inside that we need to pass here, we have first walking, and then we have jogging, and then we have here upstairs, and then we have here downstairs, and then we have here sitting as well, and apart from that we have standing as well. All right, so with this we have appended all the data frame. Let's go ahead and see now the balanced data frame shape. So now after this it says that walking, actually that's the mistake here. All right, so it says that the data frame is having 21,330 values. Now let's go ahead and see the activity of this balanced data frame. So there we have the activity column. Inside the activity column, let's go ahead and see here a value counts, and this says that all these activity, the number of values, actually the number of data samples is equal for all other activity. So this is a balanced data set. Now we have our balanced data set. Let's go ahead and see first few lines of a balanced data set, which we can see with head, and this is a balanced data set. Now this activity is actually a string. Now we need to convert this string into a categorical variable, which we can do with a label encoder. And to call the label encoder, we need to first import a label encoder, and that we can do from Scikit-Learn dot preprocessing import label encoder. All right, so let's go ahead and first create here a label. Label is equal to label encoder. All right, and then I'm going to add this new label, that is will be known as label is equal to label dot fit transform. All right, so in this fit transform I'm going to encode this activity. All right, so these activity like walking, upstairs, jogging, standing, sitting, downstairs, etc. will be encoded into a categorical variable. All right, so let's go ahead and once again see head of this balanced data set. Now you will see here this is encoded actually. All right, so inside this label it is encoded, and if you want to get the classes of this label, you can just call here classes. Label dot classes, you will get all these classes which is encoded. So the downstairs is encoded into a 0, jogging is 1, sitting is 2, this is 3, this is 4, and this is a 5. All right, perfect. So let's go ahead. Now we have encoded our data set. Here this is a feature space XYZ, and this label is our predictor, which will be as an output or a target variable. Now since you can see one more thing, that XYZ is not having a same variance. All right, so they are not in same variance. What we need to do here, we need to bring this into a same variance level. That's when we need to standardize our data. So let's go ahead and standardize our data. And for standardization, what we can do actually, we need to first take it into X variable. That's mean let's go ahead and read a feature space that we can read with the balanced data. And then we are going to read here the X, and then here we have Y, and then we have finally Z as well. And apart from that, here for Y we have balanced data, and for Y we should take only label. All right, so with this we have got here a label, I mean the feature space and the output target variable into X and Y, and the Y is having a perfect the balanced data. Now apart from this, let's go ahead and standardize our X here. So how we can do that? With a scalar is equal to standard scalar, and there I can just call here scalar dot fit underscore transform. All right, so with this X here, let's go ahead and we have got our X. Let's go ahead and create here pandas data frame, and for that we get here the data is equal to X. All right, and then here we have columns is equal to, which we need to provide here X, Y and Z. All right, and then apart from that we are also going to add a final value Y that will be actually considered as a label. So here we have label is equal to Y dot values. All right, so let's go ahead and see our scaled X, which we can see here. So X, Y, Z, I mean the feature space has been scaled and it has been brought down in a single variance. So there is not a much variance shift in between X and Y. All right, so this is the time to pre-process this data. I mean we need to make it into a frame. Why we need to make it frame? Because let's say if some person is doing an activity, then that person will do that activity for some time. Let's say 2 seconds, 3 seconds or 4 seconds. So what we are going to do, we are going to take first 4 seconds of the data, because with only these 3 values we cannot make a predictions what person is doing. So what we need to do, we actually need to make a 2-dimensional data. All right, so we will be taking the 4 seconds of the data, which we will consider just for a single activity, and then for next 4 seconds data and next 4 seconds data. The moreover, what I am trying to say here is that, let's say this is the activity for 10 seconds. Okay, so what we can say, so let's say this is the data for a 4 seconds. So with these 4 seconds data we can make a prediction, and then finally we can consider next 4 seconds data to make a prediction. All right, so this is the proper way to do that. So we need to prepare our first data so that we can make a predictions on a batch data. So let's go ahead and type here frame preparation. All right, so for a frame preparations we need to also actually import SciPy here. So let's go ahead and import SciPy stats as stats. All right, so here fs we have already defined that is equal to the 20, and the frame size for which we will be predicting our activity, that will be the 4 seconds. That's mean fs dot 4, which is actually is equal to 80. That's mean for 80 samples we will be reading here 80 samples, initial 80 samples, and then 3 dimensions. So overall data which we will be feeding to our neural network, that will be 80 and then cross 3. All right, so it will be the 80 cross 3. And the hop size means how much we want to I mean let's say if we have taken 80 seconds data, then in the next time whether we want to go ahead to take next frame from 80 seconds onwards, or do we want some overlapping. So that is the hop size here, and here we have hop size is equal to fs and then multiplied by 2. All right, so with this we have got our the constant variables. Now let's go ahead and define a functions to get our frame. So I have already written that functions to get our frame. Let me copy it, and you can get this notebook from video description, link of this notebook in video description. So here it says that we will be getting a data frame for 80 second, and it will be making an increment with for 80 data samples, and it will be making advancement with 40 data samples. And we have a number of features 3, that's mean X, Y, and the Z. And this is the data frame which we will be passing, and this is a frame size, and this is a hop size. All right, then we will be reading here, see I, and then plus frame size, and this is a hop size. So we'll be creating here a range for our actually time frame, and that will be advancing with the size of hop size. All right, and then with that hop size we will be reading from I to I plus frame size, that is 4 second. Let's say if it is a 0, then 0 to 4 second for all these X, Y, Z. And if this is a 4, then 4 plus 4, that is 8, that's in 4 to 8 second. And we will be doing this for a full data set, so X, Y, Z. So what we are actually doing here, we are preparing a data sample of 4 second, 4 second, 4 second, and 4 seconds for all the data samples. And from here, what we are going to do, for those 4 seconds, we are getting a label which is maximum number of labels. For example, let's say if we go get a 4 seconds of data which contains 5 and the 3 as well. So we are going to consider the activity which comes most number of times, we are going to consider that, and that we are calculating with the modes. So here we have stats.mode, and in that label we are considering a most number of time which it occurs. All right, then after that I'm going to add here that XYZ frame size, and then this is a label. All right, and then finally this list is being converted into a numpy array, and then it is returning here our X and the Y. All right, so this is a feature space, and this is our target variable. So let's go ahead and run this function, and after this what we are going to do here, we are going to get our X and the Y into a feature space. Let's go ahead and call here get frames. In that we will be passing here our scale X, which is a standardized X, and then we have already defined our frame size and hop size as well. All right, so with this we have got our X and the Y. Let's go ahead and see a shape of our X and the Y. Now one thing you might notice here is that earlier our shape of X was 3555, but now it is 532. Why? Because if you divide it by 532, you will get here something like this. All right, 6.67. So actually what is happening here, it is actually it has it has made that a frame of 4 seconds. All right, so that 4 second frame actually coming here, instead of that if you divide it by 80, then you will get exactly. All right, so all right, so actually this is 3555 for one activity. Then we need to also multiply by 6 to complete it, and then you see here we get something like this. All right, so this is 266 if we include 80, but since hop size is just 40, then we need to make it 40. All right, so it says that we get something 533, but here there is already a minus of frame size. That's why we have got here just 532 samples of X and Y. So this is our X and Y. Now we are ready to call our train and the test split. So let's go ahead and call our train and the test split, which we can just do by calling X train and X underscore test, and then here we have Y underscore train, and then Y underscore test is equal to train test split, and there we are passing here X, Y, and then here we are passing here test size. All right, so here we have the test size, which is 0.2, and then the random state, I'm going to pass here a random state which is actually a 0, and then here we have a stratify. A stratify is equal to Y. All right, so with this we have actually our the splitted data into training and the testing sample. Let's go ahead and check this shape of X train and the test as well. that you can see here in training sample we have got 425 samples, and in the testing samples we have got 107 samples. All right, so this is our three-dimensional data. But if you check just single dimension data, I mean at the 0th location, that is stored at the 0th index, and you see here at the 0th, this is just a two-dimensional data. But our convolutional neural network accepts a three-dimension. All right, so to do that, what we need to do, we need to reshape this. And for reshaping, what we can do, x underscore train is equal to x underscore train dot reshape. All right, and there we need to reshape it 425, and then we have 80, and then we have a 3, that is for x, y, z, and then 1. And similarly we have for x test as well, there we have x test dot reshape, and in that reshape we have 107, and then we have 80, and then finally x, y, z, and this is 1. So in this way we have reshaped this data, and now if we check it, now we have a three-dimensional data. All right, for each of the data samples. All right, so this is done, our data pre-processing. Now we are ready to go ahead for our model building. So let's go ahead and build a 2D CNN model. All right, so this 2D CNN model, what we are going to do, we are going to first call a sequential layer so that we can add the other layers as well. So there we have here a sequential layer, and then here we have a model dot add, and in the first layer I'm going to add a two-dimensional convolutional neural network, that's the conv 2D, and then here I'm going to pass a 16 filters, and if you press shift and the tab, you will see other parameters which it takes, the like filter, kernel size, stride, and other things, and then 16 filters. And apart from that, I'm going to pass here 2 by 2 kernel size, which is a filter size as well. You can see the activation functions, universal activation function ReLU, and for a first time, I mean at the first layer, we need to also pass here input shape as well. That's the input shape, and there we have here our x train, and for a 0th locations we can just pass here a shape. So this is the first layer of convolutional neural network. Let's go ahead and implement a dropout here. So here we have a model dot add, and then here I'm going to drop randomly 0.1, that means the 10% of neurons. All right, perfect. So apart from that, then again I'm going to add the another layer of convolutional neural network that I can do with conv 2D, and here I'm going to pass 32 filters, and the size of each filters will be 2 by 2, and the stride size will be the default, and the padding will be also default. The activation functions I'm going to pass here ReLU. All right, and if you remember here in hidden convolutional layers, we don't need to provide input shapes because it automatically matches with these preceding layers. And let's go ahead and add here a dropout, and then here we have a dropout of 0.2, which is 20% of a dropout. Let's go ahead and do here model dot add, and then here model dot add, then here we have a flatten. All right, then here we have a model dot add, and then here we have a dense layer. All right, so in this dense layer we have a 64, and then here we have activation function which is equal to ReLU, and then here we have a model dot add, and then here we have a dropout. All right, so the dropout I'm going to implement here 0.5, that's mean the 50% of neurons will be dropped randomly. Let's go ahead and add a final layer which will be also a dense layer, since we need to classify into 6 classes. For those 6 classes we will be needing a 6 units of dense layer, that is a 6, and since it is a multi-class classification, that's why we will be also taking here softmax as well, a softmax activation function. And we have built our model. Let's go ahead and compile this model. So for compilation, we can pass here the optimizer, and in the optimizer I'm going to pass here optimizer, Adam optimizer, that is stochastic gradient descent gradient optimizer, And a learning rate for this, I'm going to pass here 0.001, which is actually a default learning rate. And then a loss function, which will be used here, that will be a sparse categorical. All right, so that will be a sparse categorical, the cross entropy. And then here we have a matrix as well, and in that matrix it has accuracy. All right, so the model will be evaluated based on the accuracy. Now let's go ahead and record the model training into a history, and then we have reached into a most exciting step, which is a model.fit, where we will be fitting our model with x_train and then y_train. And then here we have epochs, where number of epochs we are going to use 10. And then we have here validation data. In that validation data, I'm going to pass here x test. And then finally, I'm also going to pass here y test as well. And the verbose, I'm going to pass here is equal to 1. All right, so it has started the training, and you see at the very first step, it has 24% training and 42% of validation accuracy. But after 10 epochs, you see it has 93% of training accuracy and 89% of validation accuracy. With only accelerometer data, this can be treated as a fantastic accuracy. And you see after 6 or 7 epochs, model has started overfitting. So it has reached maximum accuracy of 91.59%. And at that time, validation training accuracy was just 84%. So it has overfitted somewhere here, you can see, after the 6 to 8 epochs. So only for this accelerometer data, this is the fantastic accuracy, and perhaps this is the better than the original paper implementations on which they have implemented this. So this is the good accuracy, but if you include gyroscopes and magnetometer data as well along with this accelerometer, then definitely you can achieve accuracy of 97 or 98% with the human activity recognitions. All right, so let's go ahead and now plot a learning curve. So I have already written a code for a learning curve. If you remember in my previous videos, I have been using this code. And if you are watching first time my video, you can go ahead at my channel KGP Talkie. There I have covered a plotting learning curve and confusion matrix. And this is a video where I have shown a lot of the things how you can plot a learning curve, and you can know more about this. So basically here these two lines of code are plotting accuracy of training and validation set, and these two lines of codes are plotting loss of training and validation set. So let's go ahead and run this cell, and apart from that, let's go ahead and call this plot learning curve, in which we need to pass here the history of our learning. And then we have trained it for 10 epochs. Let's go ahead and run this. So you see here, we have got here a fantastic accuracy, and as you can see, our validation loss is less than a training loss. So we can say that our model is neither overfitting and nor underfitting. So with this, we can make sure that we have achieved 90% of the accuracy. All right, so this is about the learning curve. Now let's go ahead and see how you can plot a confusion matrix. So with the confusion matrix, we can understand how actually our classes are being classified, like walking into sitting or sitting into walking, all those kind of things we can know with the confusion matrix. But for a confusion matrix, we have here, you can go ahead and watch this video, which is here in very detail. And we will be also using this library for confusion matrix plot, that is the ML extend. You can go ahead at this link, and then you can write pip install ML extend to install this library, so that we can plot a confusion matrix in just one line instead of using Seaborn. All right, so let's go ahead and import plot confusion matrix from ML extend dot plotting. Import plot confusion matrix, and then from from Scikit-Learn.metrics, we will be also importing here a confusion matrix as well, and we will be also importing here I don't think we need matplotlib. All right, so with this we have imported here. Now let's go ahead and get the ypred on the test data. So here we get ypred is equal to model dot predict classes. So we are going to use here predict classes instead of just predict. So predict classes give you x underscore test. All right, so with this we have got the classes in ypred. Let's go ahead and get confusion matrix. We can get with confusion matrix, and then we can pass here y underscore test, that's the true value, and then here a predicted value. And once we get this, then we are going to plot our confusion matrix. All right, so the plot confusion matrix, and in that if you see here in confusion matrix, otherwise press shift and double tap, you will see here a detailed documentation, the parameter which it accepts. Then I'm going to pass here a mat, and then I'm going to also pass here a class names, and class names we can get from label, from where we had encoded our labels, and then classes. All right, so with this we have got the class name. Let's go ahead and show the probability of all the classes as well, I mean the accuracy. So with this we can get the accuracy, and apart from that we can also set here the figure size with the fig size. So we are going to set here figure size of 7 cross 7. All right, so with this now you see if we make it actually the true, then we will also get the accuracy. So now you can see, so this is the fantastic, and we get the 100% of accuracy in case of a sitting, and similarly in case of the standing we get 100% accuracy. But if you see in case of walking, we get just 94% of the accuracy. And in case of the upstairs, this upstairs is getting confused with the downstairs, right? So this is actually this is logical. So the upstairs and the downstairs could be the same, so kind of same. So that's why it is getting a little confused. That's why we are getting a very low accuracy in upstairs and the downstairs. And apart from that, we are getting here a perfect accuracy, almost a perfect accuracy in all other cases. Like sitting and standing is being classified with the 100% accuracy, and the walking is with 94% of accuracy, and the jogging is also 94% of accuracy. So this is all about in these lessons. I have shown you how you can accurately classify human activity using accelerometer data. But if you really want to increase the accuracy of this classification, then you can use the more dimensional data and the more data. And apart from that, you can also tune with the frame size and the hop size, and you can also tune the model like learning rates and the convolutional neural network layers or other things to improve your model. Now apart from that, you can also save this model, which you can just call that model dot save weights. So with this you can actually save these weights, and that's it. So with this you can save this weight and it will be saved here. All right, and then finally you can use this weight in real-time classifications. All right, so this is all about in this lesson. Thank you so much for watching, and please do not forget to like and subscribe this channel. Bye bye, have a nice day.